Hello there, my friends. Thanks for tuning in to Nerdy Nawg-Dawg Productions, and today we are talking about factors. So, a factor is a number that can be multiplied by another factor to achieve a product. So if I'm talking about the product of 12, I can always find one factor to work with any digit. And in this case, 1 times the product itself always gives you the answer of the product. So both 1 and 12 are factors of 12. There's some others though too. 2 times 6 and 3 times 4. So these, when I have two digits or two factors that equal the product, I can call this a factor pair. So 1 times 12 is a factor pair, 2 times 6 is a factor pair, 3 times 4 is a factor pair that each make the product of 12. If you were asked to list these factors, or list the factors of 12, you would want to list them down below from least to greatest. And you would simply list them like such. And then we would say that 1, 2, 3, 4, 6, and 12 are all factors of 12. Now, I feel like there's an easier way, especially as your numbers get bigger. I like to use what I call factor rainbow. And this is a pretty way, but what's so nice about a factor rainbow is it keeps our work nice and neat. I'll show you what I mean. Let's see here. So with a factor rainbow, we work from left to right, starting with one factor that we always know is in each and every digit. I have limited space here, so I'm going to write real small. But one factor of any product is always the product times 1. So 1 times 36 in this case gives us the product of 36. And then I look at my next digit. Now, one way to find out if a number is a is a factor of the product is you can ask, well, is 36 divisible by 2? And then I can also use my divisibility rules. And I know that if this product is an even number, then it is always divisible by 2. So as we're learning division, I understand division might be more challenging. You could also use mathematical reasonableness. And so I could also take what I do know about multiplication and see if I can get close to 36. So I happen to know just off the top of my head that 2 times 15 would give me 30. So that's getting close, not close enough. So then it gives me a jumping off spot, and I know I need to go higher. What if I did 2 times 17? Oh, 34. Still not quite there. So then I might choose to do 2 times 18, and that is the correct factors to make 36. Okay, so if we don't yet know our division, we can always use multiplication to give us a jumping off spot to figure out where to go next. Okay, so next up, I would go to 3. And I do know from my divisibility rules, just looking at these two digits, both are divisible by 3. Therefore, I know that 36 is divisible by 3. And if I'm looking at my fact family, I could say 3 times something is going to give me 36. Well, in this case, it is 12. And I'm running out of space with my rainbow. So then I would go to the next digit. And in this case, 4. I do happen to know that 36 is divisible by 4, and I know that 4 times 9 gives me 36. Okay, so now I'm doing my factor rainbow. I think I have space for one more here. I happen to know also my doubles, and 6 times 6 gives me 36 as well. What's nice about factor rainbow is then we have everything lined up from left to right. If you are asked to list all the factors of 36, I would move from left to right and list them all. The only thing is you do not write a double twice. So in this case, from least to greatest, 1, 2, 3, 4, 6, 9, 12, 18, and 36 are all factors of 36. Okay, let's talk about primes and composites since we're talking so comfortably about factors, my friends. The definition of a prime number. Prime means that it is only has the factors of 1 and itself. So for instance, the only way I can make 7 is by multiplying 1 times 7. Okay? We cannot use the factor of 2 times something, 3 times something. It just won't work. If I scoot all the way up to 107, guess what, friends? It is not divisible by 2. It's not divisible by 3, 4, 5, 6, 7, 8, 9. The only two factors that you can use to multiply to come up with the product of 107 is 1 times 107. Okay? That is the only way it can be done. The definition of a prime number is that the only factors in a prime number are 1 times itself. Okay? Whereas if we're talking about a composite number, it means that there are multiple factors, sometimes only 4 factors, but there is more than 1 times itself as a factor to make up that number. So if I'm talking about 24, I can make 24 in many ways. 1 times 24, 2 times 12, 3 times 8, and see how I kind of go in order? It keeps me organized. 4 times 6. Okay, so there are multiple factors that make